Welcome back. So this videos we're going to see is analyze SQL injection attacks practice lab. So we are going to perform the following task. We need a Wireshark. So using Wireshark to analyze network traffic and identify targets. Using Wireshark to identify methods used by the attacker, analyze exploit to determine specific attack vectors and vulnerabilities exploited. So let's go for practice lab. So I have the sample already. So the during SQL injection, so I just captured that. So I have now open. So I have now open with the Wireshark. So the Wireshark is open now. So for the first, we have to check the three handshake. So sync, acknowledge, and acknowledge. First three is very important. So after that, you can just notice here is the HTTP, the fourth one, and then get from home new sticker and sticker PHP is something is suspicious. So you can also double check here. So hyphenate the HTTP protocol. In the HTTP protocol, you can see the get here. So it's clearly saying the HTTP subtree in the middle frame by clicking here. So something is a suspicious, the whole list number. So 1 to 20 here you can see. So normally after a client browser sends an HTTP GET request to a web server for a specific resource or page, or as we have seen here, the web server will respond with the status codes and dynamically generate the client side code, HTML, JavaScript, so and push it back over the TCP connection to the requesting entity. So now we can go ahead and double click the packet 4. So let's spend some time to find if we find anything. So here just double click. Sorry, it's a little bit slow. So it opened the packet 2. So I'm going to open the packet 4. So in the packet 4, you can see here, so in the packet 4, so we can see if there is any suspicious. So just scroll down to see the information, the get information. So just pay same specific attention to verify the next line, so which shows the HTTP GET so request that was sent to victim web server in the attempt to conduct the SQL injections. So the 27% is a URL. So the percentage here you can see. So the person 27 is a URL encoded single code, which is the simplest way to conduct an SQL injection attacks by sending a URL encode single code input into a web applications that accept users input and interact with the backend database. An attacker can try to break the SQL database fuzzing engines and causes an error by making the number of SQL codes it uses for delimiting delimiting data uneven. So after sending this vulnerable SQL database a single code, an attacker will frequently also send additional legitimate SQL query in order to get the database to disclose internal information. So please make sure just the percentage 27 is very suspicious, So the first one, okay. Then next one. So we are going to create. So we're going to create the TCP stream. How do we? So all you need to, on the packet 4, right click, follow TCP stream. So a new window will open now. Okay, it's open. So we will now begin analyze the TCP stream. So you can see the first ones as a get home new sticker, as we know already. So the get request for, so we see initially the get request request for the resource on the victim web servers and the embedded SQL injection in the URI. So after that, we can see 200k response code followed by some HTML and JavaScript. So this code was generated by the web servers and sent back in response to the get request. So the request itself began 214B, as you see here. So let's look further. So the JavaScript. So we can see here that the JavaScript is clearly seeing here. So until the pop. So the JavaScript. So nothing strange here, as we see some basic HTML and some JavaScript as annotated in the screenshot here. So sorry, in the page here. This is also a JavaScript pop-up window. So near the button, pop-up picture, yeah. Let's keep looking and see if the SQL injections attack worked, whether the database server responds with any information it shouldn't have. So as we continue scroll down, look at the HTML. So nothing really stand out. So there are a few buttons and some ads, a few hidden iframes, but it's not until we see 12 herf. So if there is any, yeah. So you can see here. So this is something suspicious. So what do we notice about this information combine these tags? Does it look similar to anything from GET request and the SQL injection attack? So by seeing this page, do you think attack was successful? Yes, I would say it's successful. So because the AQL injections get request was trying to get a web server to disclose one of 20 different item. So the web servers then attempt to resolve 12 of 20 requests. You can see here the 12. So the out of 20, as we seen above here, so it's 20 requests. So that is very suspicious. You can consider that suspicious as suspicious. So we can now find the hidden field. You can go and check the hidden field. So hidden field, continue on through the HTML JavaScript. We can continue across. We come across one more example, SQL injection query. So the SQL injection was trying to receive the hidden names for 20 values of the web servers, as you can see. As you can see here. So we will go further. Okay, there you go. You see the Hereford. So this is the main piece, one of the main piece of the information. So the SQL injection was trying to receive the hidden names of 20 values on the web server. So we can now save this, rebuild the page and open with the browser. Let's save this output as a HTML file. So what we can do, so we can now go here and right click and then follow TCP stream. Then we can save here. So in order to save as, SQL output or SQL suspicious. Okay, suspicious dot HTML. Okay, so now we can go to the folder. So now we can just double click, open with the browser. Yeah, so you can, so look at the browser now. So the browser rendered the HTML and JavaScript from the file we saved. So you guys see the do you guys see the SQL injection attack syntax at the top of the page here? So you guys notice here, right? So let's allow the script, just allow it. Okay, so once I click the allow blocked content, so which showed bottom, so you can see the multiple screen, the content is open, iframe content. So you'll also notice that you can also notice this browser has error message present in each of the iframe, telling as we are not connected to a network. That means that each of those iframe try to call out over the internet another resource somewhere. So but since we are not online, the content could not be accessed. As a result, the browser give us those error. So if you go back and look the HTML, look inside the iframe in tag, you will see the herf. So you can see herf. So in the herf, there you can see So you can see the source code. So you can see here href attributes to each those various link. So that's it, guys. So we begin by analyzing a network packet captures and seeing evidence of attempt SQL injections attacks. So we then followed the TCP streams and reviewed the entire request and response cycle. So we then saved off the information from the packet capture into HTML files and render it in a browser. So we found evidence of the SQL injections attack possible. So working on SQL query syntax reflected back in the client-side code that server dynamically generated and sent back in response to a GET request. So that's it, guys. Please subscribe my channel, press the bell button. Bye bye.